What if I told you scientists are building a massive machine underground to figure out why anything in the universe even exists? Imagine a world where everything, you, me, the stars, simply didn't exist. Sounds impossible, right? But that's the very mystery baffling scientists for decades. Why does our universe contain matter and not just nothing? Now, researchers in the US have kicked off a bold mission to crack this cosmic puzzle. And they're doing it by firing invisible particles through the Earth itself. Welcome to DUNE, the Deep Underground Neutrino Experiment, one of the most ambitious science projects in the world right now. And trust us, it's not just about space jargon and fancy tech. This experiment could actually explain why we're all here. To help us understand what's going on, we spoke with Dr. Mark Scott, a senior lecturer in neutrino physics at Imperial College London. We asked him to break it down without the complex science speak, and here's what he told us. At the heart of this mystery is a bizarre little particle called a neutrino. It's tiny, it's ghost-like, and it's everywhere. In fact, billions of neutrinos pass through your body every second, and you don't feel a thing. But here's the weird bit. Neutrinos come in 3 flavors. Yes, really, called electron, muon, and tau. And as they travel through space, or through us, they can switch between these flavors in a kind of quantum dance. Scientists in the US and Japan are now using huge detectors to study this shape-shifting behavior. Why? Because they're searching for the tiniest difference in how matter and antimatter versions of neutrinos behave. And if they find that difference, it could finally explain why, after the Big Bang, matter won the battle, and why the universe didn't just vanish into a puff of annihilation. But this is no ordinary science fair project. The detectors are so sensitive, they have to be buried deep underground, shielded by layers of rock and earth, just to protect them from all the noisy particles constantly raining down from the sun and space. These background particles, called cosmic rays, would overwhelm the readings if the detectors were left above ground. So what's the difference between the US and Japan's versions of this mega project? Well, Japan's ahead, for now. Their project, called Hyper Kamiokande, uses a simpler and more established water-based detection system. Meanwhile, the US is using a more advanced, detailed, but more complicated liquid argon system. The upside for Japan: their detector holds a staggering 225,000 tons of water. In comparison, DUNE's liquid argon system will manage about 40,000 tons. That means the Japanese setup is over 5 times larger, giving them a head start in this global scientific race. But don't count the Americans out yet. DUNE's tech is cutting edge. And if it delivers, it could give us the clearest look yet into the behavior of neutrinos, and maybe even the origins of everything. So, is this the new space race? It just might be. But instead of heading to the stars, we're digging deep into the Earth, searching for answers written in particles we can't even see. Stick around, because this story could change how we understand the universe itself.